Okay, so today what our objective is to look at phase shifts and vertical shifts in the general form for a translated trigonometric function in order to create graphs of the functions and identify vertical shift and phase shift. So last class we talked about using period and amplitude. So this class we're taking it and we're going to take our graph and we're going to slide it left and right. So last time we stretched it, this time we're going to shake it left and right. Now we already kind of talked about this because we said if you look at this graph, it says phase shifts and it says the graph of the cosine x is shown in blue along with the graph of a translation image. So when you look at this graph, the cosine is the one that's in blue. Okay? So if you look at the one that's in red, you might be tempted to say, hey, that's the sine curve. And you would be right. It is the sine curve. But we want to write it as though it were a translation image. So in other words, we want to take the cosine and we want to just slide it. So how far do we slide the cosine so that it becomes the sine? Well, we slide this maximum from here to here. So we went pi over 2 to the right. So that means in our translation, we had something like this, xy, and we had x plus pi over 2, and nothing happened to our y. So when we substitute that in, we're going to do the opposite. So we're going to have f of x, which is our red function, is going to be the cosine of x minus pi over 2, which is also known as the sine curve, because they're only 90 degrees out of sync. And so that's an example of a phase shift. A phase shift is when you simply slide the graph left or right. So we can see here that our phase shift for identity for all real numbers, the cosine of x minus pi over 2 is the sine, and the sine of x plus pi over 2 is the cosine. Okay? Now what we're asked to do is we're asked to consider the graph of this function where f of x equals cosine x, and it's asking us to find an equation for the image under this translation. Then it wants us to sketch the graph. So when we look at this, is anything happening to x? No. Something is happening to y. So it says y minus 2. So that means our g of x function is going to be g of x equals the cosine of x, because nothing's happening to the x, minus 2. So we're going to move our graph down. Now if you'd rather, you could write it as negative 2 plus cosine x, because that way it doesn't look like x minus 2. Or you could put parentheses around your cosine x. So what we're going to do is we're going to graph this. So in order to graph this, I'm going to go ahead and I'm going to draw, hopefully, I'm going to draw an x-axis and a y-axis. So I'm just going to make this my x-axis. And I'm going to make this my y-axis. Okay? And cosine starts in the clouds. Now normally cosine would start at 1, right? So it'd start at 1, then we would have 0, then we would have negative 1, then we would have 0, then we would have positive 1. And so this would be what my cosine would look like. And it would just keep doing that every 2 pi. Now, did we do anything here that's going to change our period? I feel like I can draw that better. So when you're looking at the equation, all we're doing right now is we're just graphing the cosine curve. And it did get a little off there towards the end. Okay, so we know this is our cosine curve. Okay? Now, it says that it's y minus 2. So what's that going to do to this cosine curve? Well, it's going to move it down 2, right? So while we were at +1 and -1, we're going to move that down 2. So we're going to go down 2. So 1 minus 2 is going to be -1. So that's going to be our new maximum. So we're going to have our maximum here. And then this was 0. 0 minus 2 is going to be -2. And then this was -1. -1 minus 2 is -3. So all that's happening is our graph is sliding down. So I'm just going to sketch a little portion of it here. Now, as you look at this, okay, in the red, that's my g of x. So this is g of x. And in the green, I had my f of x. Now, as you look at this, they're congruent. They just took one and lifted it up on top of the other. It's asking us to find the amplitude and the period. Well, our amplitude, remember we said, was the max, the difference between the max and the min divided by 2. So if we do our max, which is -1, minus our -3, and divide that by 2 to find our amplitude is going to be 2 divided by 2, which is 1. Now our period is how long it takes before it repeats. Well, we still went from 1 to 2 pi. So our period still stayed 2 pi. Now here's my question for you. What's the new range? What's our range going to be for g of x? Well, remember our range is the y values. So while our domain for the g of x is still all reals, our range is now -1 is greater than or equal to y is greater than or equal to -3. Or you could write it as -3 is less than or equal to y is less than or equal to -1. Or you could write it in interval notation, -3, comma, -1. So how did I know that? Well, I knew that because I graphed it. But without graphing it, I could have known it, because my range for cosine goes from -1 to +1. And all we did was move it down 2. So we just subtracted 2 from our min and max. So 1 minus 2 is our -1. That's our max. -1 minus 2 is our min. That's our -3. Now, just looking at this graph, what's the phase shift happening here? Well, the phase shift is how we're affecting x. So what's being done to x? Well, it says it's x minus 7 pi over 3. So since it's minus, that means we're moving it to the right 7 pi over 3. I think I had that animated. I did. Okay, so how did we get that? Well, remember, we're going to have a trig function here, and it's going to be x minus h plus k. This is your phase shift. This is your vertical shift. Our period. Does anything change the period? Well, to change the period, we have to have something divided by or multiplied by x. Nothing does, so it stays 2 pi. Our amplitude. Does anything change our amplitude? Nothing's being multiplied here, so it's just going to stay 1. Now, what are the min and max values? Well, remember that for the normal cosine, our normal cosine, the min is -1, and the max is +1. We're moving this down 2. So we're going to subtract 2. So we're going to have -3 is less than or equal to y is less than or equal, to -1. So our max is -1 and our min is -3. How would we graph this? Well, you would still graph it the same way, okay? So I'm just going to say I know that this is going to be a cosine curve because it tells me it's cosine. So I'm going to put my y-axis there. I'm going to put my x-axis here. Okay. And I'm going to count by pi over 3. So this is going to be pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3. Now, anybody know why I counted by pi over 3s? Exactly. I counted by pi over 3s because my phase shift is at pi over 3, is a multiple of pi over 3. So it's actually negative 7 pi over 3. Since it's negative, that means I'm moving to the right. So my maximum, instead of occurring on the y-axis, is going to occur at 7 pi over 3, which is here. And my maximum, we said, was negative 1. The next maximum is going to be 2 pi later. So 7 plus 6 is 13 pi over 3. That's going to be here. And then my min is going to be in the middle. So that's going to be halfway between. Looks like, oh, helps if I draw this in the right spot. There we go. So it'll be like here. And that's a negative 2, and this is negative 3. So my graph's going to do a little something like this. And it's going to keep going. So I know this is going to be a min. I know this is going to be a max. So moving my graph, 7 pi over 3, is really the same as just moving it to the right, 1 pi over 3. Because isn't that what happened? Because cosine would normally be like this. And all we did was we took that and we moved it over 1 and down. So this is actually the same as if we did the cosine of x minus pi over 3, because the period is 2 pi. Let's answer some basic questions. So let's see if we can identify, if this is the cosine curve, what's the new equation going to be? Well, my cosine curve normally starts in the clouds. And right now, instead of starting in the clouds, it's on the y-axis. So that means I have a y minus 1, because I went down 1. Normally, it's on the y-axis. The maximum this time is left pi over 4. So that means I had x minus pi over 4. So this is my h, this is my k. So to write my equation, we say it's the cosine curve. So we're going to have y equals the cosine of x plus pi over 4, close the parentheses, minus 1. And they told us to do cosine, so that's all this could be. Now, if you wanted to write it as sine, you could, but they told us this was a cosine curve, so there was no reason to think of anything else. Taking a look at this graph. Now, they're not telling us if it's cosine or sine, so we get to choose. I think it's sine. The reason I think it's sine is because right here on the y-axis is where it intersects. And it seems to intersect on our midline, which was like if our x-axis got moved down. So our x-axis basically got moved down 4 units. So we have y minus 4. And if we think this is sine, then we have no horizontal shift. So we would just have y equals sine x minus 4. Now, if you wanted to do it as cosine, you know that the cosine is off of the sine by pi over 2. So that means the cosine, which would have normally been here, slid to the right. So that means you would have had y equals cosine of x, since it went right, so that would be plus, we would have minus pi over 2, and then we would subtract our 4. Both of those will give you the same thing. Is this the sine or the cosine? Well, I'm going to go with this as the cosine because they're telling me where my max occurs. So that means instead of my max being here, my max was slid to the left, 3 pi over 4. So I have my y stays the same, my x went left. So I have x minus 3 pi over 4. So if I'm going with this being cosine, it'd be x plus 3 pi over 4. Now you could argue for the sine. That's fine. If you think it's the sine curve, it's just that instead of it being here, it's here. So then you would have y equals the sine of x minus 3 pi over 4. Because if we do it as a sine, it went to the right. Now these are some equations for electrical power and the optimal volts, okay? The volts are V and the current is in amps. So it's asking us what's the max and what's the minimum output voltages. Well, let's take a look at our voltages here. So if we're looking at voltages, what's our amplitude? So if we're looking at voltages, our amplitude is 30. So that means that I have negative 30 is less than or equal to V is less than or equal to 30 for my range. Then it says we're moving it up 20. So if I move it up 20, that means I'm going to add 20 to these. So now my new range for this graph is going to be negative 10 less than or equal to V less than or equal to 50. So what's the minimum? Well, the minimum is negative 10. What's the maximum? Well, our maximum is 50. And that would be in volts. So we do the same thing for the current. So if we're looking at the current, our amplitude is 0.25, which means for current, our range is between negative 0.25 and positive 0.25. Does anything change our range? I'm moving it up or down at all? No. So this is our min, and this is our max, because the amplitude changed our range. Now the next question is talking about phase shift. What's the phase shift between these two graphs? So if you look at the cosine curve, which is our first one, so we have voltage and it's in cosine, and our second one is also in cosine, so that makes it a little bit easier. Is there a phase shift for the voltage? The voltage has no phase shift. Is there a phase shift for the current? Yes. So the current is 5 pi over 4, and that's negative, so it's to the right. So we moved it right 5 pi over 4. And then it says, by how many seconds does the maximum current lag behind the maximum voltage? Well, since it's cosine, our cosine starts at the maximum. So we're starting at 50 here. This one is not. It's 5 pi divided by 4 behind. So if we're looking at that being 5 pi divided by 4, well, they want that in terms of seconds. So to make that in terms of seconds, we just divide 5 pi divided by 4, and we get about 3.93 seconds. So that's what happens when you have a phase shift and vertical shifts.